name compounds here. This lecture is about, first of all, identifying the type of compound, naming ions, and naming ionic compounds. The first and most important step is to identify the type of compound. If you can't identify the type, you can't name it because the rules are different for different types of compounds. So first of all, does it have a charge? If it has a charge, then it's an ion. A positive charge is a cation, a negative charge is an anion, and to name those, we'll refer to the rules for naming anions and cations. Once we've decided whether or not it's an ion, if it has a neutral charge or if it has no charge, we look at what comes first. If the first component is a metal or ammonium, then the compound is ionic. If the first one is a nonmetal, then it's covalent or molecular, same thing. If it's a hydrogen, then the compound is an acid. Identifying the type of compound. Does it have a charge? If it does, it's an ion. If there's a metal or ammonium in front, it's an ionic compound. If you only have nonmetals, it's a molecular compound, and if there's a hydrogen in front, then it's an acid. So when we're naming ionic compounds, the name consists of, first of all, the name of the cation, and then the name of the anion. So the first thing we have to do is to learn how to name ions. This is the list of polyatomic ions, and you have to memorize these. So you'll be responsible for knowing these on any test or quiz for the rest of the semester. Naming cations. If it's a metal from group 1 or 2 or aluminum, or if it's ammonium, you just keep the name as it is. If it's one of the transition metals, then you add the charge in Roman numerals. So naming cations is really pretty easy. You just have to remember that if you have a transition metal, then you have to put the charge there. For naming anions, if it's a monoatomic ion, that means it has one type of atom, you just drop the name ending and add IDE. If it's one of the polyatomic anions, you keep the name as it is. You've already memorized it. We are going to go over naming polyatomic ions, but generally you've memorized it, you know it. If it says polyatomic ion with a hydrogen in front, then you add the word hydrogen to the name. And I want to emphasize that. This is something that people tend to forget. If you have polyatomic ion with a hydrogen in front, then you add hydrogen to the name. Now remember, this is when it still has a charge. So for example, if you have sulfate and you put one hydrogen in front, then it still has a charge and it is called hydrogen sulfate. If you put two hydrogens in front, it doesn't have a charge anymore, then it's an acid, and you use acid naming rules. So let's look at naming oxoanions. These are polyatomic ions. They have oxygen in them. And there are essentially only two types, names ending in -ate and names ending in -ite. And ions ending in -ate have one more oxygen than the ions ending in -ite. If there's an anion having one more oxygen than the -ate form, then the prefix per is added to the beginning of the name. If there is an anion having one less oxygen than the -ite form, then the prefix hypo is added at the beginning of the name. For examples in naming oxoanions, chlorate ClO3 has one more oxygen than chlorite, which is ClO2. If you add another oxygen to chlorate, then you get perchlorate. Perchlorate is ClO4 with a negative charge. If you remove one oxygen from chlorite, then you get hypochlorite. So ClO2 chlorite becomes hypochlorite ClO. So here's a flow chart. If you start with one more oxygen than the 8 form, it's per 8, then you get 8. If If you remove an oxygen, remove another oxygen, it becomes ite, and remove two oxygens, it becomes hypoite. And this flow chart, all of these flow charts are on Blackboard. So examples of naming cations, we have monoatomic main group cations. For instance, sodium with a charge becomes the sodium ion. Calcium with a charge becomes the calcium ion. Aluminum with a charge becomes the aluminum ion. If you have a transition metal, then you have to include the charge. So for example, iron with a 3+ charge is iron 3. And notice that is Roman numerals in parentheses. If you have an iron with a 2+ charge, it becomes iron 2. And copper with a 1+ charge is copper 1. The only polyatomic cation you have to know in this class is ammonium, which is NH4+. For naming anions, if you have a monoatomic anion, chloride or chlorine, Cl- becomes chloride. Fluorine, F- becomes fluoride. Oxygen with a 2- charge becomes oxide. So you drop the name ending and add IDE. For polyatomic ions, here are just some examples. Cyanide, Cn-, sulfite, SO3 2-, sulfate would have one more oxygen, SO4 2-, chlorate, and hydrogen sulfite. So that one at the bottom, we have sulfite, SO3 2-, we add an H+ to it, and it becomes HSO3-, and its name is hydrogen sulfite. Alright, so let's look at naming ionic compounds now. Here's a flow chart. As I said, all these flow charts are on Blackboard. If you have an ionic compound, first you have the cation name and then the anion name. For the cation name, is it group 1 or 2 or aluminum, then you just use the element name as is. If it's a transition metal, you add the cation charge. If it's a polyatomic ion, you just use the ion name that you've memorized. For the anion name, is it a polyatomic ion? If it is, then use the ion name as it is. If it has a hydrogen in front, then we add hydrogen to the name. And if it's a monoatomic anion, you change the element name and you add the IDE suffix. So here are some examples. NaCl, the cation is sodium, the anion is chloride, so it's sodium chloride. CaF2, we have calcium fluoride. Li2O, lithium oxide. Now we have some with polyatomic ions. We have cyanide with potassium, so that's potassium cyanide. We have sulfite with iron. In order to know which iron that is, you have to figure out the charge. SO3 sulfite has a 2- charge, and since there's only one of them and there's one iron, the iron must also have a 2+ charge, so that is iron 2 sulfite. Barium always has a +2 charge. It's a main group element. We combine it with sulfate and it's barium sulfate. The next one, number 7 there, copper chlorate. Copper has a +2 charge. How do we know that? We look at the charge on the chlorate. Charge on chlorate is -1. There are 2 of them, and so therefore the charge on the copper must be +2. So since it's a copper +2, it's copper 2 chlorate. The next one, we have sodium and we have hydrogen and we have sulfate, and the name is sodium hydrogen sulfate. That used to be called sodium bisulfate, but the current correct name is sodium hydrogen sulfate. Last one there, we have a transition metal with chloride. Chloride has a -1 charge. Since there are 3 of them, the charge on the gold must be 3+, and therefore that is gold 3 chloride. Note that metals always have a plus charge. Metals are cations. You're never going to have a negative charge on a metal. Now remember, when you're naming ionic compounds, they have no prefixes. This is a common mistake that people tend to make. We don't need the prefix because we know how many there are by the charges. For instance, if we go back here, calcium fluoride number 2, it is not calcium difluoride since there are 2 F's. We know that there have to be 2 fluorides because the charge on fluorine is a -1 and the charge on the calcium is a +2. So, no prefixes with ionic compounds. 3 terms that tend to be confusing. When we have hydrogen, that is the name added to an anion that has 1 or more hydrogens in front, but it still has a charge. For instance, hydrogen sulfate is HSO4-. Hydrogen sulfite is HSO3-. The prefix hypo goes on a polyatomic ion that has 1 less oxygen than the ite form. So for example, if we have chlorite, ClO2-, then hypochlorite would be ClO-. We've lost an oxygen. Hydro is the prefix for an acid whose anion name ended with ide, IDE. So for example, if we have chloride and we put a hydrogen in front, we now have an acid, and that is hydrochloric acid. And we will talk about naming acids in the next lecture.